All right, welcome to my what is this, um, week four video explainer. So this will be the extra credit portion, or the not for credit part um, of the assignment. What we will be dealing with here is first we are going to be, I guess as a preface, we are trying to find the potential of an ordinary AA or AAA battery. And the question says, if you're not sure, find out and look at the label. So that will be part A. So I was actually unaware of this, but if you look at the battery, sure enough, that it's actually 1.5 volts, and this will actually be the same for the potential for an ordinary AA or AAA battery will actually be the same. And I didn't know this, but it's actually the difference in the potential of the positive and negative terminals. And also, the potentials are going to be the same, 1.5 volts. However, the only thing that's different among them is going to be the sizes. For a AA battery, even though the potential is going to be the same, it will just give out the output for a longer amount of time. In the second part of the problem, we have two, a parallel plate capacitor, and there is a AA battery that is connected to it. And we are given the dimensions of the plates, and they are spaced 1.1 millimeters apart. And we're going to figure out how much charge does the battery supply to each plate. One thing important to note is that I was under the impression that the shape of the capacitor was a plate, but it actually we're given the area of the plates to be 4.1 centimeters by 4.1 centimeters. So just to note that for the area when we're calculating the charge done by the battery. First, a couple things we know. We know that for the electric field, we can get that by when we have E equals Q over A, or the area, times epsilon naught to get the electric field. And we also know for the potential, we can do the electric field times that distance, or in this case, the distance between the two plates. So if we substitute that potential, we can actually find out, and then once we rearrange for the charge, we can actually find out how much the charge is given from the battery based on how much the potential of the battery, what's the in volts. So just quickly, we know epsilon naught is 8.85 times 10 to the negative 12 newton meter squared per coulomb squared, and we know that the distance of the in between the two capacitor, or the parallel plate capacitor, is going to be 1.1 millimeters, or 1.1 times 10 to the negative third meters. And we know that the area, it's going to be 4.1 centimeters by 4.1 centimeters. So since we're going to do since we're going to have to end up squaring that value, I actually made a mistake here. It's not 10 to the negative second, it's 10 to the negative fourth. So we have that potential from the battery, which is 1.5 volts, by that area, which is 4.1 centimeters squared. So that 10 to the negative, multiplying that by 10 to the negative fourth, times that epsilon naught value over the distance from in between the two plates. And we're going to get the charge given by the battery to be 2.03 times 10 to the negative 11 coulombs. And just for the discussion, portion, I actually was unaware of, I guess prior to, a couple weeks ago or a week ago, I was unaware as to how the batteries worked, and what the potential of them meant. And I would have never known that the potential for an ordinary AA and AAA battery would actually be the same. Then just applying that logic to the parallel plate capacitor that we've been working with over the last couple weeks, and seeing how the potential correlates to the charge given to each plate. I thought it's important to know how to do that. And yeah, so thank you very much.